Hello wonderful person, this is Anton, and today we're going to be discussing the asteroid we discussed previously, mostly because this one actually kept NASA and a lot of astronomers quite busy. Here we're talking about the asteroid 2024 YR4, the rock discovered on December 27th of 2024 by the automated telescope referred to as ATLAS. And though at first it resembled a typical near-Earth asteroid, many of which have been discovered in the past, as the more data came in, things got very interesting. And that's because it was not just passing close to Earth, its trajectory suggested a real possibility of hitting the planet sometimes in December of 2032. And here this chunk of rock, roughly around 60 meters across, in theory could produce an explosion somewhat similar to the now infamous Tunguska event that flattened the Siberian forests back in 1908. And in fact, the detection of this asteroid triggered something that has never been triggered before. This was the first official International Asteroid Warning Network trigger that suddenly suggested a potential chance for a collision with planet Earth, while also making this asteroid the first in history to be ranked at level 3 on the Torino scale, the scale we generally use to assess different hazards in terms of impacts. But a level 3 was still actually not that scary, mostly because it's only like 1% chance of a collision that normally only causes localized damage. But nevertheless, this was still a very important event that actually for the first time in history realistically tested how good we are at assessing these dangers and at potentially preventing them. And so because of that very high risk, space agencies did not wait around, with several agencies from different countries and several observational teams essentially focusing on this asteroid and trying to figure out the real risks, with quite a lot of different teams even gaining a priority time on various telescopes that's actually meant specifically for such events. This is sometimes known as the director's discretionary time. And this involved some of the most powerful telescopes like the Gemini South and the Very Large Telescope, with all of these observations required for a much more accurate prediction of the orbit of this asteroid in order to find out if it's actually going to hit Earth. And well, what they found almost right away was quite unusual. Not because of its orbit, but actually because of its shape. Turns out it potentially looks something like this. It was actually very flat and kind of resembled some kind of a potato or a spinning top. Or basically it was not as spherical as scientists expected it to be. And so here a lot of recent studies, some of which you can find in the description, describe this object as a kind of a flattened, irregular disk, essentially resembling a hockey puck. But on top of this, it was also spinning incredibly fast, at least compared to other asteroids. Here, a single rotation only took approximately 20 minutes, which is generally considered to be pretty fast. But because this was a much smaller object at 60 meters across, this was not super unusual. However, what this does show us is that this asteroid seems to have a lot of internal strength. So essentially, if it was spinning so fast and it was just a rubble pile, similar to, for example, Ryugu or Bennu, it would have already fallen apart. But because this was spinning fast and was a single object, it basically implied that this was a single chunk of rock containing relatively high density and tensile strength. And in terms of what it's made out of, well, it seems to be either S-type, which is rich in silicates, or possibly K-type, which is usually enriched in carbon compounds. In this case, determining its composition, its density, and its type is very important because if we actually had to change its trajectory by, for example, slamming something into it, similar to the famous DART mission by NASA, here we would want to know what it's made out of in order to predict the potential changes in its orbit. But apart from predicting its potential trajectory, researchers also wanted to find out where exactly did this come from. Or basically, is this something from the asteroid belt, or possibly from somewhere else entirely? And well, here you can actually even explore this three-dimensional map of the now known orbit of this object, which essentially tells us that it kind of came from somewhere between Mars and Jupiter. Or to be more specific, from the central part of the asteroid belt, which for astronomers is actually just a little bit unusual. Mostly because usually we expect these Earth-crossing asteroids to come from the inner part of the belt, which is much closer to Mars. And so in this case, it seems that this asteroid was potentially displaced and pushed toward us by the gravitational interactions with Jupiter. And though sometimes Jupiter is described as the protector of planet Earth, because it basically clears out a lot of dangerous rocks and also displaces various comets from hitting planet Earth, in this case it seems to have done almost the opposite. It acted as a gravitational slingshot, tossing YR4 almost exactly at planet Earth. But here we also know a little bit more because of its rotation. It seems to have a retrograde spin, meaning that it rotates in the opposite direction of its orbit. And this suggests that it migrated inward from the central belt because of what's known as the Yarkovsky effect. This is basically where the sunlight hits the surface and then creates tiny amount of thrust on the surface of the object, which ends up shifting the orbit over millions and millions of years. This actually happens to pretty much most asteroids, and this is actually the main reason why it's so difficult to predict their orbits. Mostly because the sun causes them to shift the orbit over long periods of time. Okay, so that's the basics of what this rock is and where it came from. But what about its eventual destination? So, Earth, Moon, or nowhere? Well, by early 2025, additional observations by various telescopes almost completely ruled out Earth impact. But instead it now had a relatively high chance of hitting the Moon. And this chance at first was approximately 2%, then increased to 4.3%, and according to some other studies, possibly even higher. And though by itself hitting the Moon may not sound like a big deal, for the current technology, it could be a big deal. And specifically, a lot of studies around this time started to suggest that in theory, an impact of these proportions would actually release energy equivalent to a relatively large nuclear bomb, 6.5 megatons of TNT, resulting in a crater that was at least 1 kilometer across, but more importantly, releasing huge amounts of debris. And it's that debris cloud that was a bit of a concern. In this case, it would very likely release up to 100 million kilograms of lunar rock, with at least 10% of all of this very likely reaching Earth. And though this would not affect us on the surface, it would hypothetically have a dramatic effect on all of the satellites. And so here quite a few studies suggest that this would create so much of this lunar shrapnel that it could potentially damage lots of different satellites, including mega constellations, and possibly even trigger the famous Kessler syndrome. Essentially the chain reaction, where colliding debris from satellites produces more debris and eventually destroys all of the satellites in orbit, essentially rendering the entire orbit unusable for years. With additional studies even trying to calculate where some of this debris would eventually land on the planet, in case I guess we wanted to recover it. And so with a 4% chance of a collision, this was actually making some researchers just a little bit nervous. But we finally have some, I guess, good news based on the observations from the James Webb Space Telescope. In February of 2026, astronomers used the JWST to essentially take what seemed to be some of the faintest observations of an asteroid ever recorded. And because the telescope is so sensitive, it was able to pin down the asteroid's position with extreme precision. And on March 5th of 2026, NASA officially confirmed that this asteroid now has zero chance of hitting the Moon. Instead of an explosion, it will fly past the Moon at a distance of about 21,000 kilometers or 13,000 miles. And though this may sound close, it is still a guaranteed miss. So we're not going to see any fireworks, and there's not going to be any debris. So good news for space technologies, and maybe not so good news for those of you that were actually waiting for fireworks. But I guess here's the million-dollar question. Was this all just a waste of time then? And the answer here is, well, absolutely not. In this case, as I mentioned, this was the first ever actual test of what we refer to as the planetary defense. This was a kind of a real-life dry run, using a real asteroid and actual calculations and actual observations of what in theory could be a potentially dangerous impact. Here this was a direct test of how quickly international teams and networks could respond to this, and how quickly we could come up with some kind of a resolution to all of this. And in this case, the systems worked exactly as intended. From the process of discovery and notification to the actual global effort, despite all of the challenges and all of the wars going on right now, to essentially combine power and characterize, analyze, and predict everything about this object using some of the best tools we have and using some of the brightest minds on the planet. But also actually reminding us that even different impacts on other objects, like the Moon for example, might be potentially dangerous to a lot of different technologies we physically rely on today. And so in this case, even an impact on the Moon can easily have direct effects on everything we use. But when it comes to this asteroid, the story is still not finished. We're actually going to see another flyby in 2028, and at this point it's going to give us another chance to take a look at it and possibly discover something else about it, revealing some additional mysteries. But at least for now, the Moon is safe, the Earth is safe, at least when it comes to different interplanetary dangers. So yeah, we just have to worry about the stuff that's already on the planet. But anyway, on that note, we'll definitely discuss this more in some of the future videos. Until then, thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.